Okay, so members, today we are going to see how do we use factor formulas to solve such equations, but please don't forget to subscribe to the channel. Now, we have seen many lessons about factor formula, and we are going to see how can we apply it in such equations. But I'm doing this to show that you can get angles when you have more than one revolution. This one stops at 360, then this one stops at 720, the second revolution. So now from here, we apply factor formula. So we are adding cos. So it means that we shall get this angle plus this then by 2. Then we also get this angle minus this then divided by 2. So this will be now the whole is equal to 0. So from here, so this will be 2 cos, this will be 4 theta divided by 2 theta, then this will be 2 theta divided by 2 cos theta equal to 0. So from here, you can divide through by 2, so that either cos 2 theta is 0 or cos theta is equal to 0. Then from here, is that your 2 theta is equal to 2 cos inverse of 0. Now, so that here our range is stopping at just theta to make this range be seen that if you multiply by theta, or is this range before you get the angles should be corresponding to the range we have in the question. So, if I multiply here by 2 theta, so that will be ending at 330 degrees. So it means that my angles, we first get the angles before we divide it through. Cos inverse of 0, first of all, is so that cos inverse of if that is hard for you, you get your calculator, you set cos of 0, so you get, there are many, so you get 90, or you can get 270. So, one is 90 degrees, comma, the other is going to be 270 degrees, full stop. Then from here, you can now get your theta. You divide there, you divide by 2, get 45 degrees. Here divided by 2, you get 135 degrees. Then you come to this, you say your theta is going to be cos inverse of 0, and your theta, you see, it's just ending here, it's corresponding to just ending at 180. It's at 180, cos inverse of this will just give us 9. I'm not ending because theta here is ending at 180. So from here, we have the theta will be 45 degrees, 90 degrees, and 135 degrees. When I come to this, now you still see, when I combine this, I mean this is theta, this is theta. If I combine this and this, I'll be having this angle. So you always first look for the combination. When I combine this and this, I'll be having theta plus 3 theta, that is 4 theta divided by 2. I'll be having 2 theta. So I'm going to combine these two. So this will be now 2, because I'm dealing with sine, I get this angle, plus this one, then by 2, then cos of this angle, minus this angle, sine 2 theta. So this will be 4 theta divided by 2, so I'll be having 2 sine 2 theta, then cos of negative theta, because this will be negative divided by 2, get negative theta, equal to 2 sine 2 theta. From here I say cos of the negative is the same as cos of a positive angle. So this will be, now instead I can divide these 2, goes away, so I'll be having sine 2 sine 2 theta, then cos theta equal to 2 sine 2 theta. Now here, don't ever think of dividing this with this one cancels. No, we always bring it this side and we factorize out. We don't divide it, never. So now we bring this side, we have 2, then minus, now equal to 0. So see that this is common. If you factorize it out, you have 2 sine 2 theta into now, when I move this side I have cos theta, then minus of 0. So now, either this is 0, either now, sine 2 theta is 0, or cos theta equaling 1. When I put this to 0, and I take this as what I have. So we first deal with sine theta, it will be now sine inverse over 0, and there our cos theta. Now start here, it's theta to multiply here by 2. This now will go to 360, so we are getting up to 360. So now this will be sine inverse of 0. If I have first of all 0, then we have 180, and we also have 360 degrees. Then from there, we can now divide by 2. These are the arrows that are giving you cosine inverse of 0. So divide this through by 2, we have 0, 90 degrees, then 180 degrees. When I come to this, start my theta, it will be cos inverse over 1. Now, what gives us cos inverse over 1? We have a 0, then we also have 360 degrees. Then we start this one, this 360 is out of this bed if we have theta. So it's that now this one, I remove it. So from there, therefore my theta will be 0 degrees, 90 degrees, 180 degrees. When I come to this now, we first opt out to see, when I combine theta plus 3 theta, I'll be getting 4 divided by 2. It won't give me this, so this one is a wrong combination. You rearrange so that the angles, if you add those angles, should give you a product of the angle that is already there. If I combine 3 theta and 5 theta, divided by that will be 8, theta divided by 2 will be giving me 4, and 4 is not there, so that one I can't combine. Now you rearrange. So this will be now. Now I bring this here, because this can't work and this can't work. So now I bring this here. Equal to 0. Then I check. If I add this plus this, I'll be getting 60 theta divided by 2, I'll be getting 3 theta, which is already there. So that combination is okay. There we can proceed. So this will be now 2 cos, because I'm adding cos. Then theta over 2. Then still cos of theta minus 5 theta over 2, then plus cos 3 theta equal to 0. So this will give you 2 cos, then here this will be 3 theta, then cos of a negative 2 theta, then plus cos 3 theta equal to 0. And we say cos of a negative is the same as cos of a positive. And it's that from here, cos 3 theta is common. So my cos 3 theta out, here I'll be remaining with 2 cos 3 theta. I'll be remaining with 2 cos 2 theta. Sorry for that. I'll be remaining with 2 cos 2 theta, because the same, this cos of a negative is the same as cos of a positive. Then plus 1 equaling 0. And from there, either this. We already do this if this is 0. Either this is 0 or this is 0. If this is not a 0, that one can't work. So either this is 0, cos 3 theta is 0, or 2 cos 2 theta plus 1 is 0. From here, it's the now. My 3 theta will be equal to 2 cos inverse of 0. And now it's that our line is now multiplied by 3 theta, and the range we shall be working with is going to be 0 degrees less now 3 theta less this will be 540 degrees. And this is 540 is falling here. So this is where 540 is. So now we are going to get this, we are going to use this, and then we will also use this upper 2. So you see that here, our theta degrees, cos is 0. Cos is 0 if it's 90 first of all. If it's 90, comma. If it's 270, comma. And then if it's C, when I come the second equation, this one becomes 450 degrees. And that's all. Because I can't go beyond 540. That's why I'm ending there. So you see, if I divide by 3, my answer becomes 30 degrees, comma. This is 90 degrees. If I divide here by 3, I get 150 degrees. If I come to this, it's that now my cos 2 theta will be equal to negative a half. Take this and divide by 2. So your theta here will be equal to 2 cos inverse. It's now the products are going to be, I'm having now 2 theta. So the range I'm going to work with is going to be less 2 theta, less 360. Why am I getting them? I multiply this by 2 because the angle is 2 theta. So if you multiply here by 2, this is 0 by 2, then by 2. That's why I'm adding them at 360. So because cos is negative, we get our cubed, which is a half. So our cubed will be a half here, will be our cubed. So our 2 theta, cos inverse over half, that will give us 60 degrees. But this is in the first quadrant. Now in the second quadrant, it's that it's cos is negative. We said cos is negative in this quadrant and this quadrant. Now we have our theta as 60. So the angles now are going to be 180 minus 60 degrees, comma, then 60 degrees plus 180 degrees. Our 2 theta here will be, when you subtract there, you get 120 degrees. When you add there, you get 240 degrees. So your theta you see is going to give you 60 degrees, comma, 120 degrees, like that. So therefore, the values of theta are, you arrange them, 30 degrees, comma, 60 degrees, comma, 90 degrees, comma, 150 degrees. So members, that's how we use factor formula. Don't forget to subscribe to the channel. I wish you the best. Wait for more videos about trig.